Welcome to Learning Isn't Linear. Have you ever wondered why it's winter in relation to the Earth and the Sun? Have you ever been curious why it's winter? What makes the seasons? You may think it's because of the Earth's distance from the Sun going around the Sun, but that's not really true. It actually has a lot more to do with the Earth's tilt. You know, in geometry, we talk about the three rigid motions of translation, rotation, and reflection. It's so amazing that geometry is quite literally essential for life. If the Earth didn't rotate around the Sun, or didn't rotate on its axis, complex life would be impossible. It's just amazing that rotation, the action of rotation, is essential for life, or at least complex life. The Earth is tilted approximately 23.5 degrees from the vertical. This tilt is called the axial tilt, or obliquity. The Earth's tilt is crucial for several main reasons. The main effect of the tilt is that it causes the seasons. When the northern hemisphere is tilted toward the sun around June, it gets more direct sunlight. Summer in the north and winter in the south. When the southern hemisphere is tilted toward the sun around December, the reverse happens. The tilt affects the length of daylight throughout the year. In summer, days are longer. In winter, days are shorter, except at the equator where it's nearly constant. The sun is higher in the sky in summer and lower in winter, affecting how intensely sunlight strikes the Earth. This also influences weather and climate patterns. The tilt helps distribute solar energy over the globe, preventing extreme climate differences between equator and poles. If there were no tilt, equatorial regions would be scorching year-round, and higher latitudes would be perpetually cold. The tilt varies slowly over time due to gravitational interactions, mainly with the Moon and other planets. It oscillates between 22.1 degrees and 24.5 degrees over a 41,000-year cycle. We all know now that the Earth revolves around the Sun, but what type of path does it take? Well, it takes the path of an ellipse. And actually, this path is very close to a circle, but not quite. The eccentricity of the Earth's orbit is approximately 0.0167. E equal to 0 would be a perfect circle. When this value e, the eccentricity, is between 0 and 1, the path is an ellipse. Of course, this varies over time due to gravitational interactions with the planets. Geometrically, this means the Sun is slightly off-center in the orbital ellipse, which is why Earth's distance from the Sun varies during the year. But this is not the main cause of the seasons, as we have already talked about. So again, the eccentricity of the Earth's orbit is so small. This is not what causes the seasons. It's not the distance of the Earth from the Sun, but rather the Earth's tilt at some point in time in the orbit. In my book, Learning Isn't Linear, you can find the mathematics of rotation in order to create the Desmos program that I made at the beginning of the video. I developed a formula for general rotation in the plane by an angle about a certain point. If you are learning from the free resources from this channel, then you'll love my book, Learning Isn't Linear, available on Amazon.com. It contains crisp illustrations to accompany non-standard problems with extremely detailed solutions. The link is in the description. If you get the ebook version using the Kindle, there are clickable links throughout the book to Desmos and GeoGebra projects. It is very easy to search within the book for specific topics. As you can see, chapters range from algebra to calculus. Whether you are a self-motivated student solving problems on your own, or a teacher preparing for a math class, this book is a valuable resource to add to your repertoire. Okay, till next time, and remember, prioritize long-term learning over short-term test taking.